Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter atoms. So any doubts if you have in any steps of the solutions, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it has been told that which state of triply ionized beryllium has the same orbital radius as that of the ground state of hydrogen. So we know that the orbital radius is given as a naught n square by z, n a naught n square by z, where a naught is called as the Bohr radius, which is 0.529 angstrom, and z is the atomic number of the hydrogen-like species. Atomic number of the hydrogen-like species, and n is the principal quantum number of the orbit, or I can say it is the orbit number or shell number. So now, therefore, for beryllium, for triply ionized beryllium, it means that its atomic number is 4. Its atomic number is 4. And we have to find out n, which state. Um, and for hydrogen, we know that z is equal to 1. And so it has been told that which state of triplanized beryllium has the same orbital radius that of ground state of hydrogen. So for ground state of hydrogen, R will be equal to A naught into 1 square by 1, so which is equal to A naught. And that should be equal to, for beryllium also, means A naught into N square by 4. So it means A naught will cancel, then N square should be equal to 4, so N should be equal to 2. So for the second orbit, for N is equal to 2, for triply ionized beryllium, the same orbital radius will be there. So option 2 is the correct answer. Then it has been told that if m is the atomic mass, and A is the mass number, then packing fraction is given by m is the atomic mass and A is the mass number. No, A should be here. Actually, it has been told wrong. Okay. Okay, A is the mass number. So therefore, the packing fraction is given as m minus A divided by A. The atomic mass minus the mass number divided by the atomic number. So option 4 is the correct answer. Then here it is told that the electron in a hydrogen atom makes a transition from n is equal to n1 to n is equal to n2. N is equal to n2 makes a transition. The time period of the electron in the initial state is 8 times that of the final state. We know that t square proportional to r cube. Yeah. So it means the time period of the electron in the initial state is 8 times. So it means the radius of the first orbit should be also higher. So this should be n1, this should be equal to n2. So electron has made transition from n1 to n2. So from higher to lower orbit, from higher orbit to a lower orbit. N1 should be obviously more than N2, since the time period in the first orbit is higher than time period of the second orbit. Since here it is told the time period of the first orbit, the initial state is 8 times that of that in the final state. So T1 is equal to 8 times T2. Then the possible values of N1 and N2 are. So it means that T1 square by T2 square, that is equals to R1 cube by R2 cube. So therefore, we can say that T1 by T2 whole square, that is equals to R1 by R2 whole cube. So therefore here R1 by R2 whole cube, that is equals to T1 by T2. T1 by T2 is 8. By T2 is 8. So 8 by 1 whole square. So therefore R1 by R2, that is equals to 8 is 64. So 64, the cube root of 64. So that is 4. So it means R1 by R2 equals to 4 by 1. Now therefore we know that, so it is in the hydrogen atom only. So the radius is equal to A0 n square. So therefore R1 by R2, that is equals to N1 square by N2 square, that is equals to 4 by 1. So therefore N1 by N2, that should be equal to 2 by 1. So it means that the ratio of N1 and N2 should be equal to 2. So N1 should be obviously higher than N2. N1 should be obviously higher than N2. So it means option 2 is the correct answer, since in option 2 only N1 is more than N2 and N1 by N2 is 2. So option 2 is the correct answer. Here it is told Bohr's atom model assumes the nucleus is of infinite mass and is at rest. So we know that nucleus should be at rest, it should not move, and the electrons in a quantized orbit do not radiate energy. If the electrons are in quantized orbit, they will not radiate energy, not radiate energy. And mass of the electrons will remain constant only. So it means all the above conditions are true according to the assumptions of Bohr atomic model. So Bohr's model, according to Bohr's model, the mass of the electron also should remain constant. The nucleus mass of the nucleus is nearly infinite and it is at rest also. And electrons in the quantized orbit will not radiate energy. So all three are correct. So option 4 is the correct answer. Then here it is told excitation energy of a hydrogen-like ion in the first excited state is 40.8 electron volt. So we know that therefore the excitation energy, or I can say the ionization energy, or the ionization energy given as 13.6 electron volt into Z square by N square. So it is the excitation energy or the ionization energy from the nth orbit, for the nth orbit for a hydrogen-like species having atomic number Z. Now here it it is told first excited in its first excitation state. So first excitation state, it means that it is n is equal to 1. No, n is equal to 2, first excitation state. So therefore the ionization energy that is given as 40.8 electron volt. So that is equal to 13.6 electron volt into Z square by 4, since 2 square. So therefore Z square will be equal to 4 into 40.8 divided by 13.6. So this is yes. So this is 3. 4 3s are 12. 18. That is z square equal to 12 here. Now, therefore, we have the energy needed to remove the electron from the ion in the ground state. So therefore, the ionization energy for n is equal to 1 we have to find for this hydrogen-like ion. Hydrogen-like ion. So that will be equal to 13.6 electron volt into z square by 1 square. So z square is 12. 12 into 12 into 13.6 electron volt. That will be first excited state. Since why ground state means n is equal to 1 only, it will be 12 6 is 72, we'll say 36, 36 plus 7, 43, 12 163.2 electron volts. So it means none of the options are correct. So it should be in the second excited state actually. So if it is equal to 3, n is equal to 3, so it should be the second excited state. So here it should have been written second excited state. Second excited state. So then this will be 3 3 is 9. This will be 9. So 27. Okay. Actually, this should be in the ground state. So it means that here none of the options are correct. So something is wrong here. First excited state. First excitation state means n is equal to 2 only. This will be 4. Z square will be 4 into 40.8 divided by 1.36. So 13.6. This is 18th. Okay. So here none of the options are correct. None of the options are correct here. Okay. So here it has been told that the specific charge of a proton, the specific charge of proton, it means the charge of the proton divided by mass of the proton. So it means it is E by m. That is given as 9.6 into 10 power 7 coulomb per kg. And then the specific charge of the alpha particle is how much? So it is the specific charge of proton, and then we have to find the specific charge of alpha particle. So that will be equal to the charge of the alpha particle divided by mass of the alpha particle. The charge of the alpha particle is 2 times the charge of a proton, and mass of the alpha particle is 4 times the mass of the proton. So that will be E by 2 times m. So it is half of this, half of 9.6 into 10 power 7 coulomb per kg. So that will be 4.8. For the 8, okay, 4.8 into 10 power 7 coulomb per kg. So it means that option 3 is the correct answer. Then here it is told white light is passed through a dilute solution. We have a dilute solution of potassium permanganate, KMnO4. Potassium permanganate, the spectrum produced by the emergent light is the spectrum which is produced by the emergent light, that will be, so only some of the wavelengths will be absorbed, so it will be a band absorption spectrum. So some wavelengths will be absorbed by the solution and some will be emitted. So the spectrum produced by the emergent light, that will be band absorption spectrum. And so some will be absorbed, some wavelengths will be absorbed, and those regions will be dark here, and the remaining wavelengths will be emitted. Remaining wavelengths will be emitted. So it will show a band absorption spectrum. Then if lambda 1 and lambda 2 are the wavelengths of the first members of Lyman and Bastian series respectively. So it is the first member. Lambda 1 is the wavelength of the first member of Lyman series. First member of Lyman series, it means that it will go from the wavelength of transition from n is equal to 2 to n is equal to 1. And similarly, lambda 2 is the first member of Bastian series. First member of Bastian series. Actually, the first wavelength, it means when, so energy difference here will be least, the wavelength will be highest. So the minimum wavelength will come when the transition is from n equal to infinity to n is equal to 1. And the first member of Bastian series also similarly, it will be from n equal to infinity to n is equal to 3. So therefore, we can say that 1 by lambda is equal to r z square into 1 by n initial n final minus 1 by n initial. So therefore for 1 by lambda 1, I can say it is rz square into 1 by 1 minus 1 by infinity 1 by n final square minus 1 by n2 square. Okay. Therefore 1 by lambda 1, that is equal to rz square. For lambda 1, I can say it is 1 by rz square, and 1 by lambda 2, that is for Bastian series, so it will be rz square into 1 by 3 square minus 1 by infinity square. So that will be 1 by lambda 2, that is equals to rz square by 9. So lambda 2 will be equal to 9 by rz square. So therefore lambda 1 is to lambda 2, that is equals to 1 is to 9. Lambda 1 is to lambda 2, that is coming 1 is to 9, but so I think here first wavelength, here I think it should not be infinity, it should be from, so this part is wrong slightly. first member, it means it is from n is equal to 2 to n is equal to 1, and here it is from n is equal to 4 to n is equal to 3. So this will be from n final, okay, by 2 square. So this will be rz square into 1 minus 1 by 4. So it is 3 by 4. So it means that uh, lambda 1 I can write that is equals to 4 by 3 rz. And here this will be also 1 by 3 square minus 1 by 4 square. So this is rz square into 1 by 9 minus 1 by 16. So this is equal to 16 minus 9, that is 7. So 7 rz square divided by 16 into 9. 6 9s are 54, okay, 144. So therefore lambda 2 is equal to 144 divided by 7 rz square. Rz square. Therefore, now lambda 1 we got, that is 4 by 3 rz. And lambda 2 we got, that is 144 144 by 7 rz square. It will be rz square. Rz square. Therefore lambda 1 is to lambda 2. Lambda 1 is to lambda 2, that will be equal to 4 by 3 is to 144 by 7. So it means that will be, we can, that will be actually 4 by 3 into 7 by 144. So this is 4 3s are 12, 4 6 are 24. So 7 by 108. So therefore lambda 1 is to lambda 2, that is equals to 7 is to 108. 7 is to 108. So option 4 is the correct answer. Then here it is told, the term liquid crystal refers to a state that is intermediate in between. The answer will be crystalline solid and amorphous solid. So option 1 is the correct answer. The liquid crystal, it means that it is the intermediate state. It is the intermediate state between a crystalline solid and an amorphous liquid. It means that from crystalline solid, if we heat a crystalline solid, if we supply heat, then it will transform into a liquid crystal, and then if we heat it slightly further, then it will convert into amorphous liquid. Yeah. Then here it is told, the ionization energy of doubly charged lithium, Li2 plus ion. The ionization energy of Li2 plus ion, that will be equal to 13.6 electron. No, we can say that will be, so we know that ionization energy, it means that it will go from n equal to 1 to n equal to infinity. Now we know that wavelength of transition 1 by lambda, which is the wave number, that is given as rz square into 1 by n1 square minus 1 by n2 square. So here we have to find the ionization energy. Ionization energy, that will be equal to hc by lambda. So that will be equal to r z square into hc into 1 by 1 square minus 1 by infinity square. So that will be equal to rhc into z square. Z for lithium, the atomic number is 3. So it will be 3 square. So that will be equal to 9 HCr. 9 HCr. So option 4 is the correct answer. Then here it is told, electrons in a certain energy level n is equal to n is equal to n1. N is equal to n1. At n is equal to n1, it can emit 3 spectral lines. 3 spectral lines. So the rule is the number of spectral lines that can be emitted the number of spectral lines, that can be emitted, in a energy level n is equal to n, in an energy level n is equal to n, is given as n into n minus 1 by 2. So now, therefore, here at n is equal to n1, the number of spectral lines is 3. It means n into n minus 1, n1 into n1 minus 1 by 2, that is equal to 3. It means n square minus n equals to 6. So it means n square minus n, and n cannot be negative. n should be a natural number, obviously, since it is the energy level number. It can't be 0 or negative, and it should be a natural number. So n square minus n minus 6 is equal to 0. So it means n minus 3 into n plus 2, that should be equal to 0. So n can't be equal to 2, so n should be equal to 3 here. And also, here it is told in another level at n is equal to n2, here we have 6 spectral lines. Six spectral lines. So therefore, you can say n2 into n2 minus 1 by 2, that is equal to 6. So therefore, n2 square minus n2 minus 12, that is equal to 0. So therefore, n2 minus 4 into n2 plus 3, that is equal to 0. So n2 cannot be minus 3. So n2 should be equal to 4 here. So it means that n1 equals to 3 and n1 is equal to 3 and n2 equal to 4. So the orbital speeds of the electrons in the two orbits are in the ratio. Now orbital speed, we know that mv square by r, that is equal to kz square by r square. So r will cancel. So therefore we can see that v square equals to kz e square. K is equal to 1 by 4 pi epsilon naught, obviously. So kz e square divided by m into r. So therefore v is proportional to 1 by root over r. So now r is proportional to n square, we know. R is proportional to n square. So therefore v is proportional to 1 by n. V is proportional to 1 by n. So therefore v1 by v2, that is equals to n2 by n1. So therefore we have to find the orbital speeds of the electrons in the two orbits. So v1 by v2, that is n2 by n1, so it is 4 by 3. So therefore v1 is to v2 is equal to 4 is to 3. So option 4 is the correct answer. Now here it is told in Raman effect, Stokes lines are spectral lines having the wavelength greater than that of the original line. Stokes lines means, in Raman effect, Stokes lines, it means those spectral lines having the wavelength greater than the wavelength of the original line, or I can say that they have their frequency more than the frequency of the original line. So these are called Stokes lines in Raman effect. And anti-Stokes lines means, it means those spectral lines having their frequency less than the frequency of the original line. Okay, sorry, here there is something wrong. In Stokes lines, their frequency of the spectral lines should be frequency of Stokes lines that is less than the frequency of the original line, and the wavelength of Stokes lines is more than the wavelength of the original line. And in case of anti-Stokes lines, their wavelength is less than that of the original line, or the frequency of the anti-Stokes lines is greater than the frequency of the original line. So it means wavelength should be greater than that of the original line or Stokes line. So option 1 is the correct answer. Option 1 is the correct answer. Then here it is told the principle of laser action involves, so the full form of laser is light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So it means the frequency, so uh, the amplitude of the light is increased. It means there is amplification of the particular frequency of the light that is emitted by the system. There is amplification of the light of the amplification of the light of a certain frequency that is emitted by the system, and there is stimulated emission also. Stimulated emission is there, since why it has been mentioned in its name only. There is stimulated emission, and there is population inversion also. There is population inversion also. So all of the three statements are correct regarding the principle of laser action. So option 4 is the correct answer, all of this. Then here it is told 3 levels of hydrogen atom, and so it is a hydrogen atom, and the corresponding wavelength of the emitted radiation due to different electron transitions are shown. Then so it will be that the highest energy level is having energy E3, the lower wavelength, the lower level is E2, and the lowest level is E1, which is okay. These are the three energy levels. So here E3 is obviously more than E2, which is more than E1. So therefore, here the wavelength of transition is lambda 3, here the wavelength of transition is lambda 2, and here the wavelength of transition is lambda 1. So lambda 3, so I can say that the energy of transition, which is hc by lambda 3, that is equals to E3 minus E2. Similarly, hc by lambda 2, which is the energy of transition from E3 to E1, that will be E3 minus E1. And also hc by lambda 1, that will be equal to E2 minus E1. So now therefore, if we add these two, then we will get this, means hc by lambda 3, hc by lambda 3 plus hc by lambda 1, if we do, then we will get E3 minus E2 plus E2 minus E1. So that will give me E3 minus E1, which will be equal to hc by lambda 2. So therefore, we got hc by lambda 2, that is equals to hc by lambda 1 plus hc by lambda 3. So hc I can take common and I can cancel. So this will be 1 by lambda 2, that is equals to 1 by lambda 1 plus 1 by lambda 3. So therefore, we can say 1 by lambda 2. Now if you take LCM, that will be lambda 1 into lambda 3. This will be lambda 3 plus lambda 1. So therefore, lambda 2, I can say that is equals to lambda 1 into lambda 3 by lambda 1 plus lambda 3. So therefore, option B is the correct answer. Then here it is told the spectrum obtained from the chromosphere of the sun at the time of total solar eclipses. So from the chromosphere of the sun, at the time of total solar eclipse, only some frequencies will be obtained. Only some frequencies will be obtained in the emission spectrum, and all the remaining wavelengths will be absorbed. So, so in the emission spectrum, we will have only some fixed frequencies. So it will be line emission spectrum. Will line emission spectrum. So it means option 3 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter atoms. Still any doubts if you have, then please write that in the comments. We shall obviously clarify them in the subsequent videos. Also, please install our Sapience education application where we shall upload some important um, questions based on the previous year KCET exam, which shall be obviously helpful for our exam. So thank you everyone. Bye.